Hello everyone. Have you ever noticed that for the same question, AI gives different answer? How does this work? In this video, we will deep dive into it. Let's quickly understand how the next word is predicted. In this, we will take example once upon a time. These words will be mapped to IDs according to the vocabulary mapping. And then these IDs will be passed to decoder. Decoder directly doesn't give us the next word. It gives us logits, which are unnormalized score before applying any kind of probability distribution. These logits are passed to decoding strategy, and these strategy actually determines which word will be the next. The first decoding strategy that we will discuss is greedy search. It chooses the highest probability token as next token. This does two things. First, the output is always same for same input. Also, it generates not so good output. Let's understand this through code. We are going to use Hugging Face Transformer library and GPT-2 model in all our examples. We will be first loading our model and tokenizer. We will be using prompt as once upon a time. We will be tokenizing it, and then we will be using model.generate, which will use input IDs, which are vocabulary mapped IDs for the tokens, and then max length is 50, which means at max only 50 tokens will be used. Do sample as false means that it will use greedy search. Let's run this, and it's run. Let's see the output. Once upon a time, this was our prompt. The world was a great place of great beauty, and great danger. The world was a place of great danger, and the world was a place of great danger. So it's getting repetitive after a while. Let's confirm that it gives the same output in multiple runs. So let's run it again. So yeah, the output is same. Let's do this one more time, and the output is same. So greedy search always gives the same output as it chooses the highest probability token. So the output will be always same. For more understanding, let's see the top 5 words which were candidate for the next token after once upon a time. Just I'm tokenizing the input and running this for getting the logits. Let's take the last token logits which we are interested in. As logits are unnormalized score, we will be converting logits to probabilities using softmax. Now we want to see top 5 words, and we want its probability. Also we want its indices. So let's run this, and we will be decoding it to get the token as words. So the candidates were the, I, it, when, there. So highest was probability was of the. So we saw in our output the once upon a time world, the world, the world. So the was the with highest probability. So that's why it was chosen. Now if we want to see all the words tokens probability, let's run this. So in this you can see once upon a time the next word was the world was a great place of great beauty and great. So the top 5 words were I, it, when, there, and for the next step 2 the top 5 words were world, people, to, only, first. So you can see this whole chart for every word what the top 5 words were and what was the highest probability word was there. Let's visualize greedy search. Our prompt was once upon a time. Top 3 words predicted were the, I, it. The was chosen as next word as it had the highest probability. In the next step, word with highest probability was world. But if we look closely, in the first step, if it was chosen and then was, its total probability is higher than the world. This is one of the disadvantages of greedy search. To overcome this disadvantage, there is another decoding strategy which is beam search. Here we have a parameter called number of beams, which refers to how many parallel candidate sequence the model can explore at each decoding step. Let's understand number of beams through this visualization. In this, if we have number of beams as 2, which means the model will track two parallel paths, then the next word can be the or I, and also it will track the next step as well, world and was. As we have number of beams as 2, it will only track the highest two scores words, the and I. So it will calculate the total probability of both these words at step 1 and see which will be the highest probability and choose that one. So here I and was will be chosen. Let's see what will happen if we have number of beams as 3. This means it will track top 3 words, which will be the, I and it. Then it will take the consideration of next generated token, which will be word, was and was again, and calculate total probability of all these 3 words. And then it will be chosen it and was. Once upon a time, it was. Let's understand beam search through code. So we'll load our model and tokenizer and tokenizes the prompt. Now in model.generate we have introduced number of beams as 2. Let's run this and see our output. Once upon a time I was a young man. So now it has chosen I out of 2 parallel tracks. Let's run this again, but this time with number of beams as 3. So it should choose it was. Let's see. So it has chosen once upon a time it was said that. What will happen if we choose number of beams as 1? Let's run this. So you can see that the output is same as greedy search. So when we choose number of beams as 1, this means that we want to only track the one track, which means that always highest probability token will be chosen, which will be same as greedy search. Now let's understand another decoding method, which is top K sampling. Let's load our model and tokenizer and tokenize our prompt. Here in the model.generate method, you can see we have made do sample as true, which means that the output will not be deterministic but will depend on top K, which is the model. This decoding method will choose any token between top K, which is defined as 10. So any token between 10 highest token probabilities. So as of now, we have seen greedy search and beam decoding, and both of these were deterministic in nature, which means that the output will be always same for the same input. But here it will be non-deterministic, so it will be changing, which answers to the question which we actually asked at the first of video. So let's run this and see the output. So you can see that once upon a time, the first thing to remember about. And now let's run this again. Once upon a time, the man could. So it's different. Now let's run again. And we are not changing anything here. So the sun is always shining. So now I want to show you the logit of the first step, which is all the probabilities of top 20 words, top 15 words, and only green are the ones which will be considered to randomly choose from. So it can choose world, people, two only, and we have seen that it chose sun, people. So like this it can choose out of these 10 any word. So that what means top K. If we define top K as 20, so it will mean that out of 20 word it can choose any word. One of the disadvantages of top K sampling is that you can see here whole, gods, universe were also good words which can be chosen, which were good as man, human. But because top K is only 10 and cannot be changed, it's constant. So these words will not even be considered. To overcome this issue, the next decoding strategy was introduced, which is top piece sampling. For top piece sampling, let's again load model and tokenizer and tokenize the prompt. In model.generate, we can see that do sample is again true, which means output will be non-deterministic. And how the next token will be chose will depend on top P, which is here 0.8, which means that out of all the top tokens whose cumulative sum is 0.8, a random word will be chosen. So let's run this and we can see once upon a time they would say that there was no need to do anything. Let's run it again. So you can see that the output has been changed to as they were going about their business. So it's again non-deterministic. What would happen if I choose a very low top V value? Let's say 0.012. We can see that the output is same as greedy search output. The world was a place of great beauty and great danger. So when top P is value is very low, it behaves in very deterministic way. What happens is that the cumulative sum words are very low, like one or two words. So that's why when it randomly chooses, it's like greedy search. Let's visualize it to understand top P better. So I'm just using the same prompt and getting the logits for the step 1. And for the first step, I am taking P as 0.2 to understand the concept better. And now let's present the graph. So we can see that when top P is 0.2, the top three words which can be chosen are the, I and it. So the set is very small. When we increase it to 0.3, so we can see now the set has been increased by 3 values more. If I increase it even more, so the number of words are getting larger and larger. As of now, we have seen that after top P or top K is applied, the next token gets selected randomly. Temperature parameter control this randomness. Intuition behind is that token lockets get divided by temperature. So if temperature is less than 1, it favors high probability token. But if it is higher than 1, it allows more randomness. So let's run this with 0.5. So here output is once upon a time, the first thing that came up to mind. If we run it again, the output will be different. What happens if we take temperature value as too low, like 0.1? So we can see that it mimics the greedy search because the higher probability gets more favored. In this graph, we are representing how different value of temperature affects the probability distribution. So we have here three temperatures. Temperature is 0.5 in blue, in orange we have 1, and in green we have 1.5. So 1 is normal, so it doesn't affect any probability distribution. So it will be like not applying temperature. So we can see that in orange line. When the temperature value is lower, the probability of the word gets higher. Like the world, you can see here it was around 0.21 something, and now it has been increased by 0.55. And for the next word, it goes the same. It increases it a little bit. But when it is greater than 1, which is 1.5, the probability of this world word gets little bit lesser. So it favors more randomness here. If you liked this video, please give it a thumbs up. Also share and comment.